discuss about overcurrent relay installation in PowerFactory. So for doing that, first we open the IEEE 14 bus system example in the PowerFactory by clicking on the import. And this is the system that we have. So in this system, we have 132 kilovolts in the red side and 33 kilovolt in the green side. So for example, we want to install overcurrent relay in this line, in this side. So for doing that, first we should design the overcurrent relay that we need. For designing the overcurrent relay, we need first to see how much is the pickup current. Normally the pickup current for overcurrent relays is 25% higher than the maximum rated current. And we need the TMS, and the TMS for the first overcurrent is normally 50 milliseconds or 0.05. So first we should make a load flow. And here you can see the current that going through this line is 312 amp. So we assume that this is the rating current, but the rating current should be 3 times of this one, but we assume that this is the rating current. And we should add 25% to this one. So 312 amp multiplied to 1.25 will be 390 or around 400 amp. So for installing the overcurrent relay, first right click in the cubicle that you want to install the overcurrent relay, device, relay, new. So this is a window for installation of any relay that you need. So it can be distance relay, overcurrent relay, or anything that you want. So if you click on relay type, here we have select and new. If you click on the new, you should design the relay, and it's really difficult. By using the DSL you should do that. But if you click on select type, here you have a lot of options for installation of overcurrent relay or any type of relay. So here we can see we have a huge number of relays. So for this example, we can use the cell 751 1 amp relay. Click OK. Then here we have the options or functions for this overcurrent relay. You can see here we have a lot of options based on the real relay. And as you know, for installation of the relay, first we need to install the CT. For overcurrent relay, we don't need a VT, but we can also install that one. Click on Create CT. Then you will have this window. Click on Type, New, CT type. So primary can be 1000 and the secondary is 1 amp because we use the cell 751 1 amp. Click OK. It's not necessary to change anything here. Click OK. Then create VT. For overcurrent relay, VT is not so much important. Just primary, the rated voltage. OK. And here something like this. So it's not important because overcurrent relay doesn't use this. Then we have this relay, but we have a lot of functions. So we should deactivate the unnecessary functions and active only the necessary functions. So this is the activate one and this is the deactivate one. Click on the content. Here you can see we have a lot of functions. So we only need 51A. So just check all of them except these three. Keep the logics and deactivate them again. And click close. So now we have a relay and we should design the relay. Click on 51A. Here we have the function for 51A and designing. So here we have different curves. Normally we use IEEE standard inverse. Just click on that one. And here we have the current setting. So it says that, okay, how much is the primary? We calculated the primary should be 400. So 0.4, it will be 400. Time dial is the TMS. We can put 0.05 and click OK. So for the next one is also should be exactly the same. So for other phases, 0.4, 0.05. Okay, and here is also exactly the same. Okay, so now we designed the relay, click OK. So the relay is installed here. If you want to see the curve, right click, plot, and this is the curve for the designing relay. So if you want to see that we don't have any operation during the normal operation, just make a load flow and see the load flow current is here. Now if we make a, for example, short circuit in middle of the line and execute, we can see if we have a short circuit in middle of this line, we will have operation of the relay after 426 milliseconds, which is completely good. So this is designing of overcurrent relay. If you also want to make some transients and see how is the behavior on the transients, easily you can make some RMS and EMT simulation for this one. So this relay is working well for a fault in this line. So if we have, for example, short circuit in other part of the line, for example, 90%, execute, you can see it's also working after 236 milliseconds. So the overcurrent relay is working completely well.